Hey students, we're going to go ahead and go over solution stoichiometry in this video. Now, we've had a unit about stoichiometry, and we know we have to do stoichiometry if we have to convert from one substance into a different substance. Solution stoichiometry just takes it a step further because it's stoichiometry involving, you guessed it, solutions. And we have to look at the concentrations of the solutions that we're using and how many milliliters of those solutions that we're using in a lab situation so that we can figure out that mole relationship between two different reactants or between a reactant and a product, for example. So when we're doing our solution stoichiometry, of course, you're going to want to start with a balanced chemical reaction. I always recommend writing your given information underneath your reaction so that way you can keep track of what information you have and what information what you can do with that information, okay? It just helps to organize your thoughts and see what you can do first, because you really have to figure out, what do I have enough of and what can I figure out from what I already have, okay? So when we look at this example here, we're gonna have to start by writing a balanced chemical reaction. So I've got silver chromate is going to precipitate, and I have silver nitrate reacting with potassium chromate. And both of these are aqueous solutions. I'm going to have to predict my products. Excuse me. So I'm going to have KNO3 as one of my products, and I'm going to have silver chromate as my other. And this one's going to be the solid. So you want to make sure you look at your solubility rules from previous units. To balance, I just need a 2 here and a 2 here. Now, it tells me that I'm trying to find grams of silver chromate. I'm given 150 milliliters of this, and the concentration of the solution is 0.5 grams. And then I've got 100 milliliters of this, and its concentration is 0.4 molar. So what I'm going to do first is I want to use Molarity Formula to find moles. So I'm going to use my molarity to find the moles. So I need to do this 2 times because I'm given the starting amounts of both reactants. And as we know from our stoichiometry unit, every time we're given the starting amount of both reactants, we need to figure out which one is the limiting. So I've got 0.500 molar. I'm going to try to find my moles of the silver nitrate. And I've got to put this into liters. So let me go ahead and solve for this. That tells me that X is equal to 0.075 moles of silver nitrate. Now I've got to do that same thing, but I'm going to do it with the potassium chromate. So I had to put my X on the top because I'm trying to solve for moles of this. Remember, I want to get this into liters on the bottom. I can multiply those two numbers to solve for X, and I would get 0.0400 moles of K2CrO4. Now for step 2, I'm going to use stoichiometry to find grams of my silver chromate. So I'm going to go back up here. I'm already in moles, so that means I can just go right ahead and use my mole ratio. Excuse me, that should be a 2. 2 moles of silver nitrate. And I'm going to switch it to my silver chromate. So that means I have to have 1 mole of silver chromate down here. I'm going to put my molar mass. Just trying to get myself situated here. My molar mass is 331.74 grams of silver chromate. And I can go ahead and solve. And that's going to get me 12.4 grams of silver chromate. And I have to do the same thing down here, starting with my potassium chromate. So I'm going to use the coefficients of my potassium chromate. I'm going to switch to my silver chromate. And again, I'll use that molar mass here so I can find out how much silver chromate this concentration of potassium chromate would have made. So when I solve for this, I end up getting 13.3. And as we know from our limiting reactant problems when we did these in stoichiometry, whichever one of these, the NO3 or the K2CR4, produces the least, that would be our limiting. So the AgNO3 is our limiting. How much ever it produces is how much product we're going to make. So we're going to make 12.4 grams of silver chromate. So let's take a look at this next question. It's a little bit different here. So how many milliliters of 0.28 molar barium nitrate? So we have barium nitrate as one of our reactants. And that's aqueous, because all nitrates are aqueous, are required to precipitate as barium sulfate, so that's going to be a product, when the barium nitrate is reacted with aluminum sulfate. So there's my aluminum sulfate. And I'm going to be making barium sulfate, it told me, which is a solid. And then aluminum nitrate, which is aqueous because all nitrates are aqueous. So I have to go ahead and balance this. I'll need a 3 here, which means I need a 3 here, and I'll need a 2 here. Okay, I'm going to keep track of everything that I have. So I'm looking for milliliters, and I know that my concentration of this solution is 0.280. And it tells me that I've got 25 milliliters of this, and my concentration of this is 0.350. Well, I don't have enough information to do stoichiometry first because I don't have any grams or moles or anything to that effect. And I don't have enough about the barium nitrate to do anything first. So that means for my step 1, I'm going to use molarity again to find moles. And I'm going to use it to find my moles of the aluminum sulfate. So I have 0.350 molar. I've got my 0.025 liters down here at the bottom, and then my X. So 0.350 times 0.025. So that tells me that I have my X is equal to 0.00875 moles of aluminum sulfate. Now that I have moles, that means that I can do some stoichiometry. So I'm going to do some stoich. Now, in this particular case, where am I going to end my stoich? I only need to find moles of the barium nitrate because I'm trying to find the milliliters, which means I can use that molarity equation again. So I don't need the grams of the barium nitrate. I can just do a simple mole to mole conversion here. So I've got 1 mole of the aluminum sulfate down here, and I'll have 3 moles of the barium nitrate up here. And that tells me, so I'm going to run out of room, so I'm going to write my answer down here, that I got 0.0263 moles of barium nitrate. All right, so I need to do one more step here. So that means I'm going to use the molarity formula again to find my milliliters. But this time I'm going to use the moles of barium nitrate. So I've got to use the molarity of my barium nitrate. Sorry, I forgot to color code it in the middle there. And I've got my moles, which I just calculated, so 0.0263 moles of my barium nitrate. I'm solving for X here. Now students, this is where students always make a mistake algebraically. Okay, we need to get X by itself. So if we multiply both sides by X here, and then I need to get X by itself, I would end up dividing my moles by my molarity. Okay, so students always make a mistake about that. So make sure you make yourselves a note. You got to divide your moles by the molarity. And I used my unrounded moles in the calculator to solve for this. And this tells me that X is equal to, I need 3 sig figs, 0.938, and that is liters. So remember, in order to go from liters to milliliters, I'm going to move this decimal point 3 times to the right now. So that's going to be 93.8 milliliters of barium nitrate I'm going to need to use in this reaction. Okay? We'll do one more problem. So it tells us that we've got sodium hydroxide are added to copper sulfate. So they're both solutions. This is aqueous as well. We had to predict the product, so we have sodium sulfate. Make sure you drop and swap. And we have copper hydroxide. Copper hydroxide is a solid, because hydroxides are usually solid. Sodium sulfate was aqueous because alkali metals are always aqueous. All right, so it tells us that we have 25.0 milliliters of this, and the concentration of this solution is 0.350. And it tells me that I have 45 milliliters of this, and my concentration of this is 0.125 molar. And then I'm trying to find how many grams of my precipitate I'm going to make, my COH2. So this is going to be similar to that first problem that we did, where it's going to involve a limiting reactant problem because we're given the starting amounts of both reactants. And as you can see, we don't have enough information to do stoichiometry yet because we don't have any moles or grams. So we're going to use our molarity formula to find moles. We're going to have to just do it for each reactant though, so that we can figure out which ones are limiting. So we have 0.350 molar solution. We have our X number of moles for the sodium hydroxide over 0.0250 liters. So we're going to solve for X by multiplying here. And we get X is equal to 0.00875. And that's going to be moles of sodium hydroxide. I'm going to do the same thing now to find my moles of copper sulfate. So I've got 0.125 molar solution. I'm going to have my X on the top so I can figure out my moles, and 0.0450 liters. So I'm going to multiply my molarity by my liters here so that I can figure out how many moles I have. This tells me that X is equal to 0.00563 moles of copper sulfate. So now that I have my moles, I have enough information that I can do some stoichiometry. So I'll do some stoich to find grams of my copper hydroxide. So first, I'm just going to use my mole ratio here. Oops, and I realized I've never balanced my reaction. So you always have to make sure you balance your reaction. I just needed 2 right here. Then it should be balanced. So I've got 2 moles of sodium hydroxide. And then I've got 1 mole, let me change my color so I can color coordinate. 1 mole of the copper hydroxide up here. And then I can use its molar mass on the top of this conversion factor so I can calculate how many grams. So let me figure out my molar mass here. It's 97.57 of CuOH2. So when I calculate, that's going to give me 0.427, because I want 3 sig figs, grams of CuOH2. Then I'm going to do the same thing starting with my copper sulfate though. So I've got 1 mole of copper sulfate down here. I have 1 mole of copper hydroxide up here. And then I'm going to finish it up with the same setup on as the above one, where I'm going to have my molar mass, the 97.57 grams of CuOH2 up here on the top. And then I'm going to go ahead and solve. And this one ends up being 0.549 grams of CuOH2. And so then remember, I forgot to color code there on the bottom, I apologize. So remember, I compare these 2 values to figure out which one is my limiting. Whichever one produces the least ends up being my answer for this, okay? So you have some practice for solution stoichiometry on page 9 and 10 in your packet, and I have the answers already there for you. What I want you to do is do as many problems as you need to in order to feel comfortable with solution stoichiometry. Check your answers against my key. If you think anything is wrong with my answers, please just let me know and reach out to me, and I'll double check my work over here. Or if you're not getting the correct answer and you can't figure out where you went wrong, double check with me, email me, especially email a picture of your work. That's really helpful for me to help you identify where you went wrong, if you send me what you're doing so I can take a look at that and give you some feedback. So let me know how things are going with solution stoichiometry. If you have any questions, just let me know. Thanks.